Imagine trying to report on sales using a spreadsheet that says average price is 50s. What if the price changed today? You'd be reporting lies. Imagine asking, who is the CEO? Before you can filter who reports to them. You get one answer, then you filter the list by that single person. That's a scalar subquery, a magic box returning exactly one value. Imagine trying to find a store using only its zip code. You get many matches. Now try finding it by zip and street name. That's a row subquery. We check if that exact pair of numbers exists in our map before showing the order. Here is the real power. Imagine calculating a team average, then filtering employees above that average. You can't do this in one simple join because you need the result of the first step to define the second. This table subquery builds the temporary list first, giving us modular logic. You might wonder why we avoid nesting too many of these. Imagine asking for a city name inside every single customer row check. This forces a fresh calculation for each person, which slows things down massively. Here, the bad pattern repeats that inner query thousands of times unnecessarily. The rule is simple, keep them flat or use joins when you can. In short, too many nested scalar queries kill performance. Here's my honest take. Joins are great, but they fail when you need dependent logic. You can't easily say, give me sales only where the average is above X with the join alone. Subqueries solve that by calculating the threshold first. The downside is memory overhead compared to a clean join path. Use subqueries only when the relationship or logic demands it. In short, joins lack dynamic dependency handling. So here is the trick. Know how the engine processes these differently. A scalar subquery runs its inner part for every single outer row, which adds up fast. A table subquery builds a temporary set first, which uses more memory but fewer repeated passes. The diagram shows where execution time spikes if you go too deep. In short, nested logic multiplies database cost significantly. Let's look at the structure visually. Imagine a flow where an outer query feeds into two distinct inner types. The scalar branch returns one value for comparison, while the table branch returns a set to join. Notice how arrows point from outer to inner in both cases clearly. This helps you spot patterns when reading complex SQL scripts quickly. In short, parentheses inside select define the subquery pattern. Here's where to apply each type effectively. Scalar subqueries shine when checking a single metric like an average price across categories. Table subqueries are perfect for creating temporary views or CTEs that simplify logic flow. Row subqueries feel niche but great for matching exact tuples in rare cases. Stick to scalar and table unless you have a specific tuple match need. In short, match the query type to your logical goal. So let's recap the core concepts we covered today. A scalar subquery gives you one single value for comparison or assignment. A row subquery returns a specific row with multiple columns to match against. A table subquery feeds a full set of rows into your main query logic. Choose your type based on what result the outer query actually needs. In short, match the query type to your logical goal.